So welcome to this video, and in this video we're going to look at graphing polynomials. If you'll look at this first polynomial here, there's always essentially four things you need to think about before you start graphing. You always want to think about the degree of the polynomial, okay? So for this polynomial that I'm working with here, this one has a degree of 6. Okay, so remember you have an exponent of 1 there, okay, and we obviously have an exponent of 3 and then 2, and you can think about adding those up, okay, so that'll be 1 plus 2 plus 3, which will give you 6, okay. You can, excuse me, you can also think of multiplying this whole thing out, and that leading term that you would have there would be 2x to the 6th, and then it'd be plus blah, blah, blah. But your leading term would have a degree of 6. So you can think about it either way, you'll get a 6, okay? So now what we want to think about are our roots, okay, or our zeros. So each of these factors that have an x will give us a root or a 0. Okay, now as a reminder, it's always x minus the root, okay, r for root. So this one would have to be x minus a negative 3 in order for us to have a plus 3 in the factor. So the actual root here is a negative 3. Okay, so just remember that you have to switch those signs, okay? So let's get some of this stuff out of here. All right, so we have a root of 0 from this guy right here. We have a root of 4, and then we have a root of negative 3. Okay, and what we can do is we can go ahead and plot those on a grid. So we have negative 3, 0, and 4. Okay, so negative 3, 0, and 4. All right, so now we need to think about our multiplicities. Okay, so our multiplicities are these exponents. So this root of, that's at 0 has a multiplicity of 1. This root that's at 4 has a multiplicity of 2. And this root that's at negative 3 has a multiplicity of 3. And the multiplicities tell us how the graph is going to behave at each of those roots. When you have a multiplicity of 1, then this is a linear look, and that means that the graph is just going to cross right through that, almost like a line. Okay, that's why we call it linear. When you have a multiplicity of 2, this is a quadratic look. So that's going to come to the root and then turn around and go the other direction, like a U shape, okay? And then if you have a multiplicity of 3, this is cubic. And so it's going to cross through there, but it's going to have a little bit of a bend to it. So linear, you're always going to have that kind of line look to it. Quadratic, it's going to have the U. The cubic's going to have a little bend in it, okay? So we're thinking about our multiplicities at each of the roots, and then we also need to think about our end behavior. Okay, now our end behavior, since I have a degree that is even, okay, because 6 is an even number, that tells me that either my graph is going to be up, going up on each end of the graph, or going down on each end of the graph, okay? Now, the way that you can decide between which one that is you want to look at your leading coefficient. And if my leading coefficient is positive, it's going to be this combination where it's up on both ends. If my leading coefficient is negative, then it would be that one, okay? So this particular example, we have a positive 2 as our leading coefficient, and so it is going to be this first option here where both ends are going up, okay? So now we have to put all of this together to get a graph. So I'm going to have, like I said, at the negative 3, I have a multiplicity of 3, so it's going to be cubic, and it's also going to be going up on this end. So I'm going to have my graph come down, a little bend there, and then cross on through, okay? And then when I come to my root of 0, it has a linear multiplicity. So it's going to go down, and then it's going to come back through, like I said, a linear look to it there. And then at my root of 4, it's going to have a quadratic look to it because of the multiplicity of 2. And so it's going to come and touch it and turn around. And then you want to just make sure that it's going up on both ends of the graph when it's all put together, okay? So once, it's sort of like doing a little puzzle, you just put all of these little details together and then you get the graph of the polynomial. Now for this class, we don't have to worry about how low or how high we go on these. This is going to be a local minimum, right? This is going to be a local maximum. And once you get into calculus, you actually do a lot more work with actually calculating those different local minimums and local maximums to get those more accurate. But we just need a sketch, okay? So this would be a sketch that includes, you want to make sure your sketch has your roots, it has the correct end behavior, and you want to make sure it has the correct look of your multiplicities. Okay, and as long as your sketch has that, then you have covered enough. Okay, now if we'll look over here at this second polynomial, this is basically the same example except for my leading coefficient is now a -2. So the only thing that's going to change about this graph is that the end behavior is going to be going down on both ends, okay? So my degree is still 6, my roots are still 0, 4, and -3, my multiplicities are the same. Like I said, only thing that's changing is that end behavior. So let's go ahead and get this on the graph here. So we would have -3, a 0, and a 4. And I still need that cubic look at the -3, but it's going to start from going down. And then it's going to have a little bend at the -3. It's going to come up, and then it's got to go through that 0 in a linear, and then it needs to come back up, bump at the 4, and then head back down. So once again, now we just have that correct end behavior that supports having that negative leading coefficient, okay? So just remember that if your degree is even and you have a positive coefficient, it's going to be positive leading coefficient, I should say, that's going to be an up, okay, on both ends. But then if your leading coefficient is negative, it'll be down on both ends, okay? So we can formally state that. Let's just add this in because you're going to see this in your homework. That as x approaches -infinity, your p of x is approaching positive infinity. And then as x approaches positive infinity, my p of x is approaching positive infinity. And this is just matching what we were talking about up here with our end behavior and the fact that on both ends it's going up, okay? On this guy over here, we would say as x approaches -infinity, p of x is going to -infinity, and then as x approaches positive infinity, p of x is approaching, -infinity. Almost messed that up there. All right, so this is -infinity, which is matching what we did on our graph there. Okay, so that's just how you communicate that end behavior. All right, so let's keep going to a couple more examples here. So here I have this polynomial function, and let's look at our information. We have a degree of 5. Okay, just think of, remember you have a 1 here, and that you want to just add up those exponents. Okay, and we have roots, or zeros, however you want to think about that. We have a root at 4, we have a root at -1, and we have a root at -6. So the root of 4 from this first one, -1 from this one, and -6 from that one. Okay, and then you also want to notice your multiplicities at each. We have a multiplicity of 1 at the 4, a multiplicity of 2 at the -1, a multiplicity of 2 at the -6. My leading coefficient is positive, okay? And I also want to think about putting all of this together on a graph. Now, when your degree is odd, okay, so up here we talked about when the degree is even. So this one is if your degree is odd. Okay, so 5 is an odd number. Then either your graph is going to be down on one end and up on the other, or it'll be up and then down. So it'll be opposite, okay? If your leading coefficient is negative, it's going to be this one where it's down. I'm sorry, I said that wrong. If your leading coefficient is positive, it's going to be this one where it's down on the left and up on the right. And then if your leading coefficient is negative, it's going to be this one where it's up on the left and then down on the right, okay? So my leading coefficient is positive, all right? So positive, I have a positive 5. So we're going to have this situation here where it's down on the left and then up on the right, okay? So let me get some of this out of here. All right, so I'm going to have to erase some of this so I have room to graph, all right? So let's plot our points. I have -6, I have -1, and I have 4, okay? At -6, I have a multiplicity of 2. And I also know that this is going to be down on the left side, and it's going to come to this, and it's going to have that quadratic look, so it's going to bump it and turn around. Okay, I have another multiplicity of 2 at the -1, and so let me redraw this a little bit. So it's going to come down, go up, and bump there, okay? And then it's going to come down, and then at the 4 I have a multiplicity of 1, so then it's going to just shoot through there with that linear look, okay? Once again, don't worry about how low to go on those local minimums. That's something you'll worry about later in another class. You just need to have this general sketch, okay? Remember, you need to have your roots, the multiplicities, and the correct end behavior. So on this one, if we needed to state our end behavior, we would say as x approaches negative infinity, p of x is going to negative infinity, and then as x approaches positive infinity, p of x is also going to positive infinity. And once again, that's just matching what you're seeing, okay, on the ends of the graph. Okay, so look at this other example here, okay, and this is another situation where we have an odd degree. So I have a degree of 3 on this one, okay? Now what's nice about this one is that we just have multiplicities of 1 all the way through, right? So 1 plus 1 plus 1 is 3. And we also just know it's like a linear look at each of those. My leading coefficient is negative. I have a -2, and my roots are 0, 1, and -6. Okay, so let's get this sketched here. So I've got -6, I've got 0, and I've got 1. Okay, now this one, because the leading coefficient is negative, my end behavior is going to be up on the left side and then down on the right side. Okay, so I need to make sure I start my sketch in that way. So these are each linear multiplicities of 1. So I'm going to come through the root here, go down, come through the root here, go up, and then come down through the root here. So you want that correct linear look at each of those roots. And I also want to make sure I'm up on the left, but then going down on the right. So we would say as x approaches negative infinity, p of x is going to positive infinity because we're going up on the left. And as x approaches positive infinity, p of x is approaching negative infinity. Okay, so here are a few examples of different degrees. Remember, if your degree is even or odd, that tells you how your end behavior is going to go. And then your leading coefficient helps you to narrow that down even more, whether that's positive or negative. And then you want to always think about your roots and your multiplicities, and then you need to put all that together to get a sketch. Okay, I will see you guys in the next video.